Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is divide array into arrays with maximum difference. So the problem statement goes like this: you are given an integer array nums of size n and a positive integer k. You have to divide this given array nums into segments, or say sub-arrays, not sub-arrays, actually segments, okay, or into more or one or more subarray. Segments can be from non-contiguous species. For example, we can pick 1, 1 and 3. As you can see, this part was not contiguous in the array. Okay, so these three elements were not occurring one after another. So each element of these conditions should be satisfied. Each of the segments should be of exactly size 3, and those segments individually should be satisfying these two conditions, that each element of the segments should be the difference between two elements in the segment should be less than equal to k, and there should not be the case that an element of an array is occurring between two segments. What I mean by this is, let's say array was given as 1 2 3 4, and let's take 3 size array whose size is a multiple of 3. So now size is 6. So let's say we decided to divide the array something like this. Now as you are able to see that 3 is occurring in more than one subarray, and 4 and 5 are also repeated. Okay, so this should not be the case. Each element in the array, this was the given array, should be at max present in one segment. So they cannot be present in multiple segments. So that is what this constraint is meaning, or this condition is meaning. And you have to return the 2D array or the segments array after you are done partitioning or dividing the given array into one or more subarrays. Actually not subarrays, it's just arrays. Subarrays are contiguous part, so that's the thing. And if it is impossible to satisfy the conditions, you should be returning an empty array. Okay, and if there are multiple answers, you can return any of them. Okay, and let's have a look at the constraints. So the length of the array will be a multiple of 3, and it will be of order 10 raised to power 5, and each element will also be of order 10 raised to power 5, and your k will also be of order 10 raised to power 5. Okay, so these are the constraints. Now let's see how we'll be solving this particular problem. Let's take the very first example. Since we were required that the difference of any two elements in a particular segment, this is, let's say, a single segment, then difference of any two elements should be less than equal to k. Okay, so let's say a is an element and b is an element of this segment, and we take this pair, and if let's say we want to find the difference, then this should be less than equal to k. Okay, the difference should be less than equal to k, not more than that. So let's say the value of k here is given as 2, and you picked 1 and 3. Now if you subtract 3 from 1, it will be -2, which is less than k. So we have need not to worry about, let's say, subtracting larger number from smaller. That will always give us value less than k, since it will be a negative value and k is not having any negative value, as you can see in the constraints. It's starting from 1. So we are only worried about subtracting 3 from 1. In that case, it will be 2. So for every pair that is belonging to segment, this condition should hold true. Difference should be less than equal to k for every single segment. Okay, so what we can do is we can form this particular segments array. We can divide this array into other arrays by sorting this array. Why we are sorting it? Because sorting will help us to find the number which is exactly k more than this first number. Okay, so 1 plus 2 will be 3. Okay, and each segment should be of size 3. Okay, now you will see that whether the element present at 2 indices from the first index. Let me write the sorted array completely first. 3 4 5 7 8 9. 3 4 5 7 8 9. Okay, and let's mark the indices 0 1 2 3 4 5 6 7 8. Now you will see, if you are at the very first index, you will see what is the element at index 2 indices ahead. So it was 3 and your current element was 1. So 3 minus 1 2. It is less than equal to k. So this satisfies the 2 condition. This can be a valid segment. Since we were already taking each segment of size 3, then we will move to next element. We will see whether the difference of these two is less than equal to k. Yes, indeed, that's the case. So this is also a valid segment. Then we will move to next segment and we will see whether the difference is less than equal to k. Yes, that's the case. And since 9 minus 7 will be 2 and it is equal to k, so this is also a valid segment. At last you will be returning, let's say you take another vector or array, 2D array segments, you will be returning this segments array. When you form a single segment, you will be adding it to the segments array. Okay, so let's see the implementation. And for the time complexity wise, it will be n log n. Since we are doing sorting here, where n is the size of given array, let's say this is the nums array, then its size will be n. Okay, this will be the time complexity. And space complexity wise, you will be taking some space which will be equal to nothing but n divided by 3 into 3, which is nothing but, you can see that, n itself. Since the length of the 2D vector that we will be generating segments will be nothing but its length divided by 3, and each segment will be of length 3, so this will be the space complexity. Okay, now let's move towards the implementation. This is the implementation. Firstly, we will be sorting the input array. To check for the constraints for each segment easily, and therefore forming the segment. And this is the segments array that we will be returning if we are able to divide the whole array into valid segments. Okay, and then we will be doing the division of the array. Firstly, this will be the current segment that you are forming. Then you will check if the last element is having difference greater than k with the first element of the segment, then this cannot be a valid segment. If last element is greater is having a difference of more than k with first element of the segment, first element of the current segment, then this is not a valid segment. And array cannot be divided into segments. Valid segments, you can say. And we will be returning empty array in that case. Okay, so this is just an empty array, 2D array, and we will be returning that. If that's not the case, we will simply be forming the segment, and we will be adding that current segment to the segments array, and at last we will be returning the segments array. Okay, so this is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then please feel free to use the comment section. Thank you for watching. Have a great day ahead.